Welcome to section 8.1 and chapter 8. We are going to start functions today. It's a whole new chapter. Basically today our goal is to introduce functions and just talk about some of the background of them. So let's get started. Again, we're going to introduce functions, talk about different representations of them, how to define a function. We're going to talk about domain and range, identifying a function, and then a little bit on using our graphing calculators. Actually, today, I think I'm just going to use the graphing app Desmos instead of the graphing calculator, but we will get into graphing calculators later in this chapter. So first of all, a little bit about function notation. Okay, so function, it's not like a, you would maybe think of a people function, right? Where you attend. It's a math term. Okay, it's basically where we input something to an equation basically, and we get an output. Okay, and the input is called the X value and the output is called the Y value. And you might remember that from algebra courses that you've taken in the past. And you might remember a lot of this stuff, but I'm going to treat it as you don't know anything about it. So basically how we would say this, so the notation that we use is Y equals F of X, F of X. So that is called our function notation. And again, Y is the output actually, and this is the input. So whatever we put in for F of X, basically we're putting in X, we're going to get an output of Y, and we'll demonstrate that here. So, but before we do that, let's define a couple of other things. So the variable Y is actually called the dependent variable because it depends on what the variable X in the function is. So the variable X is called the independent variable, which means it doesn't really depend on anything. It's just we're inputting that, and then we're getting an output of Y. Okay, so we could say that the expression F of 4 equals 28, and that's how we would read it, indicates that F outputs 28 when our input is 4. Okay. And a function computes exactly one output for each input. Okay, so no more than one output, basically for each input, and we'll demonstrate that as well. So and we don't just have to use F here. We could use G, we could use H, etc. Okay, not just F. These are different ways to represent functions. So we could represent them verbally, numerically, symbolically, graphically, and also via diagrams. And we'll show that here in just a second after these examples. So let's evaluate these functions, each function F at the given value of X. So what we do here, so we're given this function F of X equals 2X minus 4. And we have to determine what the output value is when X equals -3. So you might also see this as, so F of X is actually the same thing as Y. So you might actually see this as Y equals 2X minus 4. But I'm going to pretend that we are just using F of X here. So basically what we do, I'll just copy this original equation, is we take our input value of X there, and we basically put it in for F of X. Okay, so F of -3 equals, so 2 times -3 is -6, and then -4. So F of -3 equals -6 minus 4 is -10. So basically, again, what that means is when we input -3 for X, we get an output of -10. Okay. Let's do another one here. So let's so this one is F of X equals X over 1 minus X. where x equals 2. So we're going to put in 2 for x. And then just simplify it down. So we leave the f of 2 alone and we keep simplifying on the right side. So 1 minus 2 is -1. So then f of 2, 2 divided by -1 is just simply -2. So this is our answer, if you will. So when you input 2 for x, you get an output of -2. Okay. So basically, what does this mean? So basically, this means that y equals -10. Okay. So we would have maybe a point on, if you're thinking about some algebra, you would have a point on this line of -3, comma, -10, where -3 is your x value, -10 is the y value. Okay, that's basically what it means. And we could graph this line, right? This line would be y equals 2x minus 4. If you were to think back to some algebra stuff that you've done, you might be able to graph that, right? Or if you use your graphing calculator or Desmos, you could definitely graph that. And one of the points on this line would be -3, -10. And then same thing for this one. Basically, it's y equals -2 here. So then we have an x point of 2 and a y point of -2 for this. So if I graph this line, f of x or y equals x over 1 minus x, one of the points on that line would be 2, -2. Okay. So we're going to show some different representations of functions here. So remember, I talked about there's 5 different representations. So let a function f compute a sales tax of 6% on a purchase of x dollars. Use the given representation to evaluate f of 3. So a verbal representation of that could be if you multiply a purchase of x dollars by 0.06 to obtain a sales tax of y dollars. That's basically what happens. Okay, so we're trying to figure out the output. We're trying to figure out the sales tax. Okay, and we have an input, right, of whatever you purchase the item for. Okay, here's a numerical representation of that. So let's say you purchase an item for $1. Okay, the f of x value, or basically your sales tax amount, right? Your sales tax of y dollars is going to be 6 cents. Okay. If you purchase something for $2, your sales tax will be 12 cents, $3, 18 cents, so on and so forth. So that's a numerical, or kind of almost like a table representation. Symbolically, we could have a formula like so, where x is the price of the item, right? Is the price of item. Okay, so if you have a sales tax of 6%, right, you would take whatever you buy and multiply it by 0.06. Graphically, we could graph that using Desmos, and actually, I think I'm going to go ahead and do that. So let me try this. Let me do a new share. Let's see, where did I put it? Okay, I think I'm just going to share. I'm going to try this. I'm going to share my whole screen, see if that works. Oh, okay, let me do this. Okay, I might have to go back into the PowerPoint, but I think I'm still screen sharing. Let me try to go to my Desmos, wherever that is open here. I thought I had it open. So I believe I'm still screen sharing. I hope that you guys can see this. Let me just try a new share. There we go. Okay. So what I did here is I graphed this function. So we all you have to do is you could put y equals 0.06x, or you could just have 0.06x. Doesn't really matter. But cool thing about Desmos is I actually changed So if I had this, it would have kind of looked something like this. Okay, but you can zoom in to kind of change the window or whatever. So all you have to do is just type in whatever graph you want. So one of the other graphs that we had today was, let me just look back, it was 2x minus 4. So you just type in 2x minus 4, and we had said, okay, when x equals -3, what is the y value? And we can see here that at -3 and 2x minus 4, oh, sorry, at an x value of -3, at an x value of -3. So our y value should be -10, and it is. Okay, so right there, -3, -10. Okay. Okay, so that's kind of a little bit of how you use Desmos. We will use that more. So don't say, oh, that's the last time that Mr. Jacobs is going to do this. No, we're gonna come back to it. Okay. But let me go back to our PowerPoint. So we had the symbolic, we did the graphical representation. Again, it looks a little bit different than what I just showed you, but you kind of get the idea. And then a diagram just says that, you know, if it's $1, it goes to, you know, 6 cents in tax, $2 is 12 cents in tax, $3, 18 cents, etc. So each of the inputs has exactly one output. And then I said that, okay, so just for example, f of 3 equals 0.18. Let's talk a little bit more about a definition of a function. And I kind of showed you this on a few slides ago, but so a function receives an input x and produces exactly one output y. We've talked about that, and we can get an ordered pair for that, right? So an input is x, output is y. And we also call that a relation. So a relation is just a set of ordered pairs. And a function is just a special type of relation. You don't really need to know all that, but at least know that we get this ordered pair x, y. So again, each x value corresponds to exactly one y value. And we're also going to talk about the domain and range here. So the domain is the set of all x values. The range is the set of all y values. So domain is x, range is y. Domain x, range y. So in each case, we're going to determine whether this relation defines y to be a function of x. If it is a function, state its domain and range. So is this a function? Well, yes, each input of x corresponds to exactly one output y. Okay, so yes, I can say each input, or each x, I'll say it that way, each x corresponds to exactly one y. Okay, and I'll show you examples of when it's not a function. So the domain in this case, remember, domain is x values, right? Domain is x values, right? What x values are included in that? Well, it would be, and we always write this in terms of a set. So this is a set symbol. So it's 5, 7, 11 are what the x values are. I'm having issues writing that using this tablet, but let me see if I can do it a little better. Basically, it's the, if you're using a keyboard, it would be right above kind of the enter key, kind of that that bracket. That's not like a line bracket. It kind of has the squiggles in it. But range, so domain and range, R or range is your y values. So what y values are in that function? It would just be 4, 6, and 10. This one, is this a function? Well, so does every x correspond to exactly one y? So, well, we have so when x is 8, look at this, that here, when x is 8, the y value is 2. But here, when x is 8, the y value is 3, and that cannot happen. So no, it's not a function. Not a function. And again, that is because the same x value cannot be assigned, if you will. That's kind of how we just say the terminology in math, to different y values. Okay, but in this case, and I just kind of wrote this differently, I wrote this in terms of ordered pairs. So the first one is x. Remember, this is our x, this is our y, x, y, x, y, x, and y. Look, all the y's are the same. All the y's are 3s. That's okay, right? That is okay as long as the x values, right, are all different, and they are. We have -1 or -2, -1, 0, and 1. So yes, this is a function, and basically it's the same reason as A, or example A over there. Okay, and so since it is a function, we have a domain and range. If it's not a function, we're not going to define domain and range. But the domain of this is -2, -1, 0, and 1. And the range is just simply 3. Okay, let's talk about domain and range for a graph. Okay, so use the graph of f to find the function's domain and range. So this is a function, and we'll talk about why we can say that in just a second. But these arrows, so there's supposed to be arrows here on this. That means that this keeps going, okay? This keeps going up forever, basically, okay? So the graphic extends indefinitely. So the domain on this graph, remember, domain is x values. So here's our x-axis, our x values. Imagine this line just continuing to extend and extend and extend, okay? If I extend this x-axis, and if this keeps going up, it's going to include all of these x values over here. Same thing over here. This line keeps extending, okay? And it's going to include all the x values over here and basically continuing forever. So when that happens, we say that the domain is all real numbers. Okay, it includes every single number, basically. Not the, of course, the imaginary numbers, but all the real numbers. And then what is the range? So the range is what y values does this function include? Okay, well, the function here, the smallest y value that it includes is here at -4. But then it includes everything else, and it extends, right? It extends indefinitely up here, okay? So the range there is going to be y is greater than or equal to -4. We're just going to assume that it does touch the -4 there. So that is the range. We would express the range and domain in terms of inequalities, unless it's all real numbers. All right, use f of x to find the domain of f. So basically, what values of x can this be? Or if I put an x value in, does it mess this up at all? Well, no. Okay, so in this case, the domain here is going to be all real numbers. Okay, and I know it's kind of hard to explain that because you haven't seen a case where something does not work. So an x value does not. So basically, it's all real numbers because any x value that I put in gives an output. And that's so domain is all real numbers because any x value will give an output. Wasn't exactly sure how I was going to explain that, but I think I figured it out there. So here, does every x value in this function, f of x equals 1 over x minus 4, does every x value give an output? Well, no. And what wouldn't work here? Well, if we remember division, what can't we divide by? 0, right? So we know that we can't divide by 0. So what x value would make us divide by 0 there? Well, wouldn't it be 4, right? You could also do that by solving this equation. So it's basically x minus 4. What makes that 0? Well, it would be x equals 4, right? So we can't divide by 0. So x cannot be equal to 4 here. Why? Because if we have 1 over x minus 4 and I input 0 for x, or sorry, not 0, but if I input 4 for x, I'm going to get 0, right? 1 divided by 0 is undefined, right? Or we cannot divide by 0. So what is the domain of this? Well, the domain would be everything except 4. So it'd be all real numbers except when x equals 4. All right, find the domain and range of these functions. So we have this blue line, this blue function, that's y equals the absolute value of x. This is kind of what it would look like. So the domain, again, is what x values are included in this. Well, we see the arrows here. This extends forever in both directions, okay? And so this is all real numbers. What's the range? Well, the smallest y value this can be is 0. So the range is y is greater than or equal to 0, okay? The domain on this one, same thing, it's a parabola. Anytime you have a parabola or anytime you have an absolute value, it's always going to be all reals because this extends forever. And the range here is actually the exact same thing. It's greater than or equal to 0 again, just like the last one, because the smallest value it can be is 0 and it keeps going up on the y-axis there. What's the domain here? So this is y equals the square root of x. This one was y equals x squared, by the way. Y equals square root of x. The smallest x value it can be, it looks like, is 0. So it starts at the origin, if you remember that term from algebra. This graph starts at the origin at 0, 0, and it keeps going forever. So x is going to be greater than or equal to 0. And then the range, again, is greater than or equal to 0, because, again, the smallest y value it can be is 0, and it's just going to keep going. Now, it does kind of even out, but it is going to still eventually be going up, even if you get all the way over here, okay, or even farther. All right, now, in this table, when we're almost done, determine whether the table of values represents a function. So we had an example like this earlier. You can pause it and see if you can get this answer. But long story short, the answer is no, it is not a function. And that's because we have two of the same x values, okay, that have a different output. So these are 3, but this 3 gives an output of 4, and this 3 gives an output of -1, okay? So it's no, it's not a function. And that's because the input of x equals 3 produces 2 outputs, namely 4 and -1. If it was the same output, if this was 4 and this was 4, we would be fine. Okay, so if this was 4, it would be a function, but it's not, it's -1. The other way to tell if something is a function is the vertical line test. And that's when we have a graph. So If every vertical line intersects a graph at no more than 1 point, then the graph represents a function. So here we have two different random functions, okay? Are these, well, here we have two possible functions. Are these indeed functions? So yes, I could draw a vertical line, a straight up and down line through any point on this graph and not touch more than 1 point. So yes, it is a function. Yes, because it passes a vertical line test. And then this one would be no, it's not a function. So we're talking about the blue one here. Okay, because I could draw a line and this is like a red dotted line that does go through the function at more than 1 point. So no, it is not, it does not pass the vertical line test. Okay, and we could, I could go over to, I could go over to our Desmos and I could see, some different functions that don't pass the vertical line test either. So the two ones that I graphed earlier, those do pass the vertical line test. Let's do another one. So x raised to the second, let's see, minus 10, something like that. So that one's going to make a parabola actually, because it's a squared, and that one does pass the vertical line test. I could have something else maybe that doesn't. Let's say, I'm blanking on it, but basically anything that is going to form like, it could form a circle, or it could be a parabola that is, goes off to the right, kind of like we had in the last one, or off to the left. I did want to check out something here. Some of the homework assignments, and I got to be careful. I don't want you to see some of this, but let me go and see if I can go in here without. Okay, let's go to Canvas. I did want to show you guys a couple of homework questions really quick on this lecture. Okay, let's see here. Nope, I did it again. Let's see, I want to go into, yes, I want to go into this homework assignment. Let's see if I can do that. Oh. All right. Here we go. I think this will take us into it. I wanted to talk about number 7 really quick, and then number 9. So they want you to use a graphing tool to graph this. It actually says graph f using 3 points. So what you do here, and this is f of x equals 1/4 x plus 8. You could do this by hand. You could also use a graphing calculator or Desmos if you want. So 1/4 x plus 8. I do think probably the easiest thing to do is just to make a table of points. So actually, let me do this really quick. Let me open up a Word document. So they had that this function f of x equals 1/4 x plus 8, I believe. Okay, and what we can do here is we have input values. Okay, so we pick a bunch of x values and we get an f of x value or a y value. So you can pick whatever you want for this, and you might remember this from algebra, but pick any x values you want. I in this case, because we have a fraction and our denominator is 4, I'm going to pick multiples of 4. So maybe -4. Let's do 0 and 4. So if I would plug in these to my function, 1/4 times -4 plus 8, this gives me, let's see, 1/4 times -4 is -1 plus 8 is 7. If I put 0 in for this, it's going to give me an output of 8. And if I put 4 in, it's going to give me an output. Whoops, should be plus. Going to give me an output of 9. Okay, so that's what they want you to do here. So basically, I now have 3 points that I can graph. I have -4, 7, 0, 8, and 4, 9. Okay, so let me see, -4, 7, 0, 8, and then 4, 9. Let me see if I can do that. So we can click to enlarge the graph here. So what was it? -4, 7, and then 0, 8. So I would go -4 and then down, no, -4 and then to 7. So right here, so I would pick this, and I would go -4, 7, and then 0 and 8, right? So when x is 0, y is 8. And then that's actually, let's see, that's actually all that I need. So I actually can clear, let me actually clear this out. So I actually want a line. So I have -4, 7. Sorry, let me do this. It's not, let me see, it's not letting me graph a point here. Click the graph, choose a tool in the palette. Okay. I'm not seeing the, let's see, this is not a, let me get out of that. So it shouldn't, we shouldn't have to put 3 points in here. So that's a little interesting to me, why they would make you do that. You should only need 2 points. It's just a line, but we did make 3. Let's see. Let's try this. -4, 7. We had 0, 8, and then, okay, 4, 9. Okay, there we go. It lets us do it. And then now we save it, and then we can check, and that's all you have to do. And then the other, sorry about that. The other one that I wanted to show you, let's see. Oh, was number 9. Let me go to that. So it says use the graph of the function to evaluate the given expression. So f of -2, what's f of -2? So for f of -2, that's our output value. So it's basically, it's when y, let's see. Let's see, okay, f of okay, sorry. So when f is -2. So basically right here, when we have our -2, that's going to be a 0. Let me see. Yep. And then, so on this graph, what this means is when it's at -2, what is the value right here? And then when it's at 3, what is the value? So basically, -2 on the x-axis, what is the y value? 3 on the x-axis, what is the y value? It'd be -4. So that's all they want. That's all they want you to do for that. So they basically say, this is on the x-axis, what is the what is the y value? That's what they want. Okay. So that is it. Sorry for a little bit of a hiccup there on number 7 on the homework, but I figure it was good. If I'm having issues with it, with that graphing tool on there, then maybe you would as well. So I hope that was useful of your time. Sorry for the little bit of a longer video, but we'll see you later.